Okay, so to get started, the first thing that we're going to cover is basic input and output. So far we've covered really how to work with data from within Python. We've worked with, you know, how do you create a variable, how do you create data structures and sets of data from within Python itself. But what if you want to get input from a user? Like what if you want a program that will respond to input from the command line when you're working with it? So how do we do that? The first thing that you'll need is a command called the input function, which you'll see on the screen here. The input function essentially says whatever's in between the parentheses, that's a message I'm going to give to the user whenever they run the code, and I'm going to sit and wait until I get a response from the user. So if I were to run this code here, you can see it says name equals input, provide your name here. If I were to run this code, the first thing, it would come up at the bottom here. It says provide your name here. So what it's doing here is, it's going to sit and wait until I type something into this box here. So if I type Alex, that's my name, and hit enter, it will then proceed to the following code within that code block here that says print welcome comma name, and that it'll just say welcome Alex. So when you get input from this from this input function here, you can assign it to a variable like I did here called name. In this case, that name is just going to be a placeholder for whatever the user typed in, and then you can use that in print statements, and you can use that for computations later on in the code. So you don't just have to take strings, and you don't just have to get strings and words and letters from the input function. You can also get numbers. However, one thing that's very important to realize is that the print statement only accepts strings. So if you try to do something like, 3 plus 4, and that gives you a number, and then you try to print the number, the print statement will most likely throw an error because it's not a string. So if I type here, number equals input, provide input, or provide a number to add to 3, and then I create another variable called result, which is 3 plus whatever number I type in, and then I try to print the result, it should throw this error that you see below here. So I'll type 4, and it'll give it a minute. And you'll see type error, unsupported operand types 4 plus. So so actually that's what I said here is incorrect. What the input function does is it will always convert whatever you have to a string. So when I typed 3, or so when I typed 4 here, it said, okay, that's going to be a string with quotation marks with the letter 4 in it. Now 4 isn't a letter technically, but what the program did is it interpreted that 4 as if it were a letter or a character, and so it tried to add a number to a letter to what it was pretending to be a character, and that doesn't work. And so it never got to the print function. So before we send this notebook out, I'll make sure to correct that. So the other thing is that that's one thing. And it is also true that it is also true that with the print statement you want everything to be a string. If you try to print a number connected with strings in there, it will most likely throw an error too. So you can also so one of the things you can do here in order to fix this error that we had above, one of the things I can do is I can put this int, this int function in front of the number that I got from the input. And what that will do is it will convert the number that I typed in that Python for some reason thought was a string or a character, and it will convert it back to the number it was supposed to be. The thing about this is that most of the time with most of the time with Python, you won't have to deal with type conversions like this. That's technically what this is called, is a type conversion. Python does most of that for you in the background, but there are going to be situations where you have to be aware of what data types you're working with, and this is one of those. So in this case, if you want to add 3 plus whatever number you got from input, you have to explicitly convert it to an integer or a number in this case. Okay. Are there any questions on that before I go on to the next thing? So are there any questions from the chat that? Okay, cool. So just as a reminder with that, the input, when you use the input function, you will always get, what it will give you back is always a string. So it will always consider it a word or a letter. So if you try to do, and that's perfectly fine if you're trying to do just simple text manipulation. But if you're trying to work with, but if you're trying to do math with that input function, you need to explicitly convert whatever number you get from the user to an integer or to a numerical data type, either an integer or a floating point number, or so on and so forth, before you can do that. So the next thing we're going to cover is command line arguments. So most of the time when you're working with Python, you'll either be working in a Jupyter notebook like this, or you'll be working in just a text editor, in which you write code and then run the code. As you go through more and more code, you'll find a lot of programs are what are called command line programs. And so if you're on Windows and you've ever seen like the command prompt or the PowerShell or a terminal interface, that's what Python will end up using in the background. And sometimes you'll want to be able to get the things you type after that. Command line is a more advanced thing. We won't really worry about what that is, but it's good to see how Python gets those things in. And in order to get that, there's something called the sys package and sys.argv. argv is the list of things that go after the program that you feed into the program at first. So it's the list of things that the Python program that you're running itself is getting in as soon as it starts running. So in this case, you'll see that we have just a list of just a whole list of like a Python program, which is, you can tell because it has .py as a suffix here, the -f command, which is something internal to this, and it leads to a file which actually is this file that we're seeing. argparse is another way of doing that. That's a kind of cleaner way of getting command line arguments from a user, and this is a useful thing if you've ever worked with a command line program and you've seen these things where you have to type the name of the program and then -i, -f, and a whole bunch of command line options. argparse makes it really easy to make those things work. The next important part of input output is reading files. So a lot of times when you're working with Python programs, you're going to need to get data from the outside. You're going to need to get data from the outside world, and you're going to need to get more data than just what a person can type into the input. Because I mean, you don't want to ask the user to type in 300 numbers at once. That's not going to work well. So one thing you might want to do is type in a whole list. You might want to type in a whole bunch of data into a text file, and then from that text file you might want to read that. You might want to then proceed to read everything that was in that text file there. And this command here is how you do it. You start with a with command, and that with command open something called a context, which in this case just means that everything within this block of code is relating to what I put after this with statement. So then I say open and then the name of a text file, and then in quotation marks, this R thing here in quotation marks means read. So this means whatever text file I put here, I want to be able to read it. And as F means F is just giving a shorter name, so I don't have to type out a really, really long variable name. So then once I have this, I've got the file opened and available to me to work with in Python. Then I can type lines equals f.readLines, open parentheses, close parentheses. And it will then, and what it'll do is it'll read all the lines in that text file. And what this will do is it will proceed to, if this file existed, which for some reason it doesn't because we're in Colab, and yeah, it works fine on that. It works fine on there. So what this would do is it would read the lines, and then I could loop through each of the lines and print them out to the screen, and it would print out a whole bunch of text from a text file that I just read in. That's one of the that reading text files is one of the most important ways of getting data into Python. So even though one thing to note is that even though it threw an error on here, that's because of the environment I'm working on right here. The notebooks that you all have should work just fine. So a lot of times with reading text files, if you're working with something like big Project Gutenberg books, or really big text files that consist of various forms of unstructured data, survey results and things like that. This is a really nice and easy way to get that data into Python to then work with later on. And we'll see an example, and if we have time, we'll see an example later on towards the end of this notebook that actually uses unstructured text to actually do something pretty cool. Another thing you'll want to do, another thing you'll want to do rather often is writing data to a file. So once you've done all your computations and you've done all your math or your work, or you've done all your work with text or various other forms of unstructured data, you might want to write those results to a file so that you can to a file somewhere so that you can save them for later use. Because one thing to keep in mind is that once you turn this notebook off, if you haven't saved the file somewhere, then you might have to rerun everything to get back to where you were. So one thing you can do is we can just quickly generate a little list of numbers here, like for i in range 10 numbers.append I. And what this will do is create a list of numbers from 1 to 10, or from 0 to 9, sorry. And then again, I can use this with open construction again, except this time in quotation marks, instead of R, I have W, and that means write. And then I use as out again, and what this does is it says, okay, open this file called output.txt and open it in writable mode so that I can write stuff to it. And that W will also create the file if it doesn't already exist somewhere, if it doesn't already exist on your computer. And then I want to give that file the name out so that I can refer to it later in the program. Then I loop over the list of numbers, and I write the number to the file. This \n here thing is just an ASCII code, which means new line. So whenever you see \n, think the return or the enter key on the keyboard. So new line. So if I run that, now there will be now on this environment I have, and you'll have the same environment or a similar environment. You'll have a file called I'll have a file called output.txt. And now to see if this actually did what I wanted it to do, and actually wrote to a file, I can then use the with open statement again, but in read mode instead of write mode. And I can read the file back in and print each of the lines to see if it actually did what I wanted it to do. And as you can see, I was able to open the output.txt file that I wrote a list of numbers to. I was able to read all the lines, and then I was able to print each of the lines to the screen, and it gave me the 0 through 9 that I expected it to. So this is really important, because if you're doing really complicated statistics or computations, you don't want to have to hand write all these numbers down once you get them. You'll want to be able to have that put to a file somewhere that you can then open up later on and look at. So being able to read and write files from the outside world gives you something called persistence with it gives you something called data persistence within this sort of a computational term. So what it really means is that once the Python or Jupyter session closes, you still have the output data. And so the file that you wrote is no longer dependent on you having Python there. As long as that's because now in writing it out from Python, you've separated it from Python itself. So you can then go off and do whatever you need with that later on. Are there any questions about that so far?
Somebody online asked.
Yep.
Where the files exist in the same directory as the notebook. Correct?
Yes. So the files will exist in the same directory, in the same folder as the notebook itself. You can specify that in the place where you put the file name in the with open statement. So if you want to put it in a different folder, you can type things like folder 1 slash folder 2 slash et cetera, et cetera, et cetera. And the division, now the folder divisions are different on Linux and Windows. So if you're working on a Windows system, it'll be backslash instead of / So you can specify that where you want the file to be written out to if you want. But in the examples that we're showing here, yes, they're just in the same directory as the notebook.
Can you create a folder, Will?
To create the folder? Or?
Yeah.
If the folder doesn't exist, you'll probably want to create the folder, because I don't think Python will. Yes, there's a way to create. Yes, you can. You can use Python to create the folder, but it's a little complicated, and you wouldn't want to do it. Huh? Yeah, you probably wouldn't want to do that. You'd probably want to create the folder first and then use Python to write files to it. So are there any other questions? Any other questions online? Okay. So the next thing we're going to look at here is reading and writing data with CSV files. If you've ever worked with Excel spreadsheets, or if you've ever worked with CSV files or Excel spreadsheets or things like that, CSV files are something called a comma separated value. And in Excel, you can actually take your spreadsheet and you can save it as a CSV file. CSV files are just really just so you can transfer between different spreadsheet programs. And CSV files show up a lot in data analysis because of the fact that CSV files can be transferred between different spreadsheet programs. A lot of people will save their data as a CSV file and then distribute that instead of the Excel spreadsheet, just because if somebody happens to be working on a Mac or a Linux computer, they may not have Microsoft Excel. So in that case, you can actually, so in this case, you actually can, Python actually has the capability to read CSV files. So if you have a whole bunch of data in a CSV file that you've saved from an Excel spreadsheet, you can actually use that. You can actually read that into Python and then do computations or data analysis using the data from that CSV file. And the way to do that is to import use this import CSV function. And what this does is it imports the CSV library from within Python's standard bunch of functions, and that will give you access to all of the functionality you'll need to be able to read the CSV file. Reading a CSV file is very, very similar to reading a data file. To reading a data file like we saw before. You start with open and the file path. In this case, just something like data.csv. And I can even save data.csv to a variable called file path, and I can put it in here if I want. And then I can call that. I can give that a alias called CSV file. Could also probably type R in here too. One thing to note is that if I don't type R in the open function, Python will default to read mode. So if I were to not put this up here, Python would assume that I meant I want to read that file, not that I want to write to it. So the next thing we do is we create a thing that's called a CSV reader. There's technical terminology for that. It's called an object, but that's a more advanced thing. For now, we'll just call it a thing that Python builds that does the reading for you. So you create this reader, and you tell it where to find the CSV file, and you tell it what kind of separators between columns it's supposed to expect. Since it's a CSV file, it's supposed to expect commas. Sometimes you can get really strange delimiters, like you can have bars separate columns, or you can have semicolons separate columns. But in this case, we're just going to go with the standard CSV with a comma. And then again, you can loop over for row and reader, which in this case, what it'll do is it'll read each row in your data file, and it'll print out the row. And if all goes well, you should get something similar to this. If you're working on the actual notebook in Open On Demand, you'll see there's another block of code above this that actually writes the CSV file first. That's just so that I didn't have that I put there so you didn't have to have the CSV file exist in the first place. So if you run all of that code, and then what you should see is something similar to what's on the screen here. It won't be exactly the same. Yours will be a little bit different. And again, we can not only read from a CSV file, we can write to it. One thing to notice is the format of the data that you get back. If you look at what the CSV reading code gives back, which we saw before, you'll see that it gives you these things in brackets and everything's in quotation marks. So what it's giving you back is each row is a list of strings, like we saw back in session 2, I think. So you'll need to keep that in mind, and especially because each of anything that's a number there will also be interpreted as a string. So yes. Sorry?
The string problem is just because you are opening the file with open?
No, that's actually the default read. That's actually the default way that CSV files are read into Python. You'll get back a list of, every row will be a list of strings, even if there's a number in there that's actually a string. So anytime when you get to, so what you'll need to do is do that that string to number conversion I showed before with the print statement. You'll need to do that to convert numbers that should be numbers back to their correct data type. Python's a little weird. Python's a little weird like that.
There's only when I open the pandas and NumPy that I get everything.
Yes, if you use pandas and NumPy, it will work differently. But with this CSV library, it does read everything as a list of strings. Mm-hmm. So we can also write data to CSV files. So in this case, if we create a list of lists, where each list corresponds to a row in a table of data. So if we create a list like sample, number, quality, and read, which are that's just bioinformatics stuff, and I'm not a bioinformatics person, so I made up all these numbers and letters. So if we just create a data table like this, and we want to write, and let's say that this is the result of some big computation we've been doing before, and we want to make sure we save these results for later on. If we want to write a paper on them or publish them somewhere, we want to make sure that you don't have to go through each and every step that we've done before to get to this. So in order to write that out, we do the with open again, and we again put the output file path, which in this case is just testout.csv, and we open it with the W mode, which again means write, and we give it a nickname called out file. Then within that write context, so to speak, we create another thing, which is whose job it is to write data to that output file that we just opened. And we tell it that we want it to be in CSV format by telling it that the delimiter is going to be commas. And then again, we loop over every single one of these rows in our data table, and we write that row to the actual CSV file. And we can actually open that file again and check to make sure that it actually wrote everything to the file as we expected. And if we do that, we will see that what we get back is the list of strings that corresponds to the data table that we created above. So now there's a file. In the same folder as the notebook called testout.csv, which will now contain all of that data. So you can then take that, put it into Excel or Stata or SAS or do a whole bunch of other stuff with it. You are no longer dependent on Python, on having that whole process to create that data in Python available to you. Okay, so that's the main stuff for reading and writing files. Are there any questions on that? Any questions online? Okay. And one thing to mention is we had a question earlier on that mentioned that was asking about why Python reads, or why CSV files are read as lists of strings, and that's due specifically to the CSV. Huh? I'll get to that in a minute. The reason Python reads and writes in CSV, or reads CSV files as lists of strings, is due specifically to the CSV package that we're using. If we were using a more sophisticated package like NumPy or Pandas, which are non-default packages that you would have to install separately from Python. Those work differently, and those could actually distinguish between numbers and strings. But CSV file comes with your bog standard Python, so we wanted to introduce that first. And the question, what was the question again? Oh yes. So there's actually another mode aside from just read and write. There's also another mode here called A. The question was, is there a way to append to like add stuff to a file that you've already written to? And you can do that. You can actually change this mode from W to A, And what it will do is it will open an already existing file and add things to the end of it instead of overwriting it. Good. So are there any other questions? Any other questions online? All right. Okay, so the next segment is going to be about error handling. So you may have seen throughout this workshop so far that we've gotten a lot of errors that look kind of like this. You get a bunch of red stuff. Python underlines stuff in red, and it says exception, error, all this sort of stuff. Errors are actually very important. Errors are actually very important to report in a code because you want to make sure, because it's very important to make sure that your code is working exactly how you think how it's supposed to work. So when you write your code, you need to be very careful to check for places where something could go wrong. Either something could go wrong in the flow. Maybe the input could be not quite formatted right. So the way that we can check for that is something called an exception in Python. And exceptions basically just allow you to write a message that'll tell the user what the error actually was that happened, and the exception will also contain a bunch of other information that'll tell you where else in the code that error happened. So in this case, for example, let's say I've got a few variables here. I've got a DT variable, a DX variable, and an alpha variable. If anybody here is in engineering or anything, this stuff is kind of similar to stuff you might see if you're solving the heat equation, but that's not really important. What is important here is that we can check to see if this DT variable which is a time step, is too big. We want to make sure it's not too big. And so we check to make sure that it's greater than 0.05. So we want to check and make sure that it's smaller than 0.05. So if it's too big, if it's too big, you know, we can say within the context of a program, if that time step is too big, maybe something bad happens. So we want to check and make sure that the user doesn't select a DT variable that's too big. So if they do, though, we can use these words here, raise exception, and what that will do is it'll basically create an error within Python and say, okay, the user asked for a DT variable that's too big, and then you can actually type within this exception what you want to tell the user. So you can actually control the error message that you give people. So, for example, if we know we're checking to see whether DT is small enough, and that check fails, then we want to make sure and put in this exception what exactly happened. And in this case, we can say error DT is too big. It has to be below 0.05. And if we run that, huh? I had that right the first time. Sorry. So yeah, in this case, we want to check and make sure that DT is actually smaller than 0.05. So you can see that in this case, I made DT 0.1, and that is much bigger than 0.05. So I asked for a time step that's too big. And in this case, what Python did is it said, is it checked to see if DT was bigger than 0.5 in that, or to see if DT was smaller than 0.5 in this if statement here. And then ran this, and then when this came back true, because DT was too big, it went in and did this. It went in and did this raise exception thing. So it said, okay, the user asked for a DT that was too big. I'm going to throw an error, and so it throws an error, and the text that's within that is the error message that the user gets back, and you can kind of see, and you can see here that the message it gives back is both the error message along with some information called a traceback, which basically just tells you where this error occurred within the code. And that can be really useful if you have a very long, if you've got a very long or very complicated code. It's really useful to use exceptions as opposed to just like print statements, because then the code will stop once it encounters an error. It'll tell you where the error happened, and it will tell you, and if you wrote the error message well, it'll tell you what the error was, and then that'll help you. That can help you debug things and go in and check and see where things went wrong or what happened. And it's also good. That's also good because that can help you that can help users too of your code figure out whether or not their input is invalid. And so they might need, and so in that case, you can sort of tell people, that's too big. You need to pick a smaller value. That's the wrong type. Don't put. That's got to be a number, and so on and so forth. So, are there any questions on exceptions? Any questions online? Okay. So the next thing that we're going to cover with regards to this is we're going to discuss something called try except blocks. So try except blocks are another way of handling errors they're another way of handling errors as opposed to just if statements and if statements with raise except or raise exception. In this case, what it allows you to do is it allows you to say, okay, Python, try running this set of code, and if something goes wrong, then raise an exception and tell me what happened. So this kind of gives you a way of segmenting your code a little bit so that you can say, okay, try this first and tell me if something goes wrong. Then we can have another try except block. Try this, tell me if something goes wrong. And try except just gives you a quicker way. It just gives you a little bit more control over the full extent of the amount of code you can run. So, and it also prevents you from having to type out exactly the condition that went wrong. So if there's multiple things that could go wrong in a segment of code, you might want to use the try except block over just an if statement. So for example, if this with open statement here that I've got here, if there's a couple of different things that could go wrong here. Either the file might not exist, in which case there wouldn't be any file to read, and there would be an error thrown. Or maybe I typed the file path wrong, or maybe the file is owned by somebody else, and so I'm not allowed to read it. So there's a few different things that could go wrong here, and rather than having to write out if statements to check every single one of those, what I could do instead is say, just try running this. I could say try, and then that block of code, and then so that means just try this block of code and tell me if something goes wrong. And then it will, and then generally once it does that, it will tell you if something goes wrong. So if multiple things could happen, you'll get a much bigger traceback. You'll get a much bigger traceback here than you otherwise would. And this is kind of useful if you don't want to have to deal with multiple cases all at once. Okay, so Are there any questions regarding that? Are there any questions online? Okay, that was actually the entire input, output, and error handling session. So there's a couple of hands-on activities at the end here, and I provided solutions for those hands-on activities. The versions of the hands-on activities that are on your notebooks will have the correct file path that I just changed in there. So these you will have the solutions that you have on your notebooks will actually work. Those have been tested. The version that I have is running on an old version for some reason. So there's a couple of hands-on activities here. You can open a file and read lines of text from it, and I provided a solution below for how to do that. You can also create a set of 100 random normal numbers and then write them to a text file. And I've given you a solution on how to do that. And there's a couple of others, such as create a short program to compute the average and raise an exception if something goes wrong. And there's solutions for all of those. So if there are any questions, let me know.